Hello everyone, welcome back. So this time let's try a little bit more difficult example. Once again, it's a group problem, so grab a friend or a stuffed animal. I mean, hey, honestly, people talk to rubber ducks here in programming, so don't feel weird. So what do we have? Well, we have a bent rod. Why do we have this bent rod? I don't know, we do. And it's supported by smooth journal bearings. Why are they smooth? It means that they can't resist a force in the linear direction, the direction that goes through the journal bearing. Also doesn't resist a moment, at least around the journal bearing. It can twist if you want it to. Obviously, this thing is so twisted it can't twist anymore. F is equal to 800 newtons. We see that it's 30 degrees from the x-axis, and it is 60 degrees down from the xy plane. So remember, for these kind of problems, break it up into two 2D problems. First, find the z component and the f prime component, and then break that up in f prime component into x and y components. You can do it, believe me. So I would never send you forth without a plan, so here's your plan. Draw for your line diagram, and then solve. Okay, that's not much of a plan, but you can do this. You've been doing it a lot, so let's get to it. So I'm going to pause here. You're going to go off and do what you need to do, or you're going to go forward like, by cheating and just saying, you know what, I'm just going to watch the whole video. Don't do that. Try it first. So pause here, and in 3, 2, 1, we're back, and now let's do it together. Let me turn on my fancy little laser pointer. So first thing we need to do is to actually draw everything, okay? Draw it all. So we have AX and AZ here, we have BY and BZ here, the journal bearings that keep motion from going perpendicular to the axis of what's going through them. And then CY and CX up here. We have a force F. Now, before we can even solve these equations, we probably need to break F up into its components. So this is done fairly quickly here, so I want to break that down for you just so you can see exactly what was done. So when you're doing this, you always want to break it up into two 2D problems. And it looks like this. The first one I'm going to do is the triangle I just drew. So I'm going to redraw it. And then down. Okay, and this is F. So I know right here that this is F and that this is 60 degrees. I have to name everything. Well, this one right here points in the Z direction, so this would be FZ. And this one right here doesn't point in the X or the Y direction, it points in both, so we call it F prime. So we know that F is equal to 800. So then we know that adjacent over hypotenuse is cosine. Adjacent over hypotenuse. So this one is adjacent to the angle. It's right next to it. So 800 cosine of 60 would be the x prime component, which we're going to see right there. And then 800 sine of 60, because sine is opposite over hypotenuse. This is opposite of the angle. So opposite over hypotenuse is sine, so 800 sine of 60 would be my FZ component. And we see that right there. Okay, so we know that F prime is equal to 800 cosine of 60. And so now that we've done that, we're going to go ahead and do our second 2D step. So I know what F prime is now. I need to break that up into an X and Y, a Y and X component. So let's go ahead and do that. And I'm going to draw this like this. Here is my Y component. Here is my X component. And I have an angle. I kind of reversed everything, which is always weird when I do that. Okay, F prime here. This is Fy. And this is Fx. So you see we're not having to do really anything in 3D. We're just breaking up into 2D steps. And then everything's exactly the same. Adjacent over hypotenuse is cosine. So we get cosine of 30 times F prime to get our X component. Opposite over hypotenuse is sine. So we get sine of 30 times F prime for our Y component. And in the end, we finally have all of our answers. There you go. Beautiful. So we've broken up F, and now we need to write our scalar equations of equilibrium. Scalar equations of equilibrium. Now, as a note, you do need to think about where you are calculating these at. For some of the forces, it doesn't matter. You're not picking a particular point and saying, I'm calculating the sum of the forces at point A or point B. It's just for the entire free body diagram. So that one's simple. And we have some equations here, okay, 2 unknowns, 2 unknowns, 2 unknowns. That's 6 unknowns. 3 equations, not enough. Luckily for us, when you have a 3D problem, you get 6 equations. There you go. So let's look at them. So we have some moments in the x, y, and z directions. And I can do this around any point I want. I can even choose several points. So you have to think about the place that's going to help you do this the best. So where are you going to do it? Which one makes the most sense? Well, let's see if we can guess where they calculated this one, because they didn't actually mention it here, and I want to see if you can figure it out. So cy times 2 plus bz times 2. This one was around the x-axis, so I'm trying to calculate around here. Okay. And also you notice that there are no a components in these. The only way they could have gotten rid of those a components is if they calculated the moments around point A. But I could have very well done around this point, this point, this point, any point I really want. I should try to pick a point that makes things simple. Okay? The simpler it is, the better it is. So, they did around point A. You could have done around other ones. In the end, there's no real good point. Just choose one of these, because that will make it easier. I like the fact that they chose point A. Just makes sense. All the measurements come from that, so it kind of makes it a little bit easier. So with that, we have 6 equations, and you're like, oh no, algebra. Yeah, there's algebra here. You're going to have to solve these. However, this is one of those points where I strongly suggest you learn how to use your calculator, because yes, there's a whole lot of algebra in here, but it can be set up as a matrix. You can actually solve this using your calculator, if you have a graphing calculator. Just by putting all these as a system of equations, where you have like ax, ay, or ax, az, by, bz, cx, cy. All those are unknowns, and you put all their values for each equation. And then you can solve by taking a determinant, which might be going way over your head. But for now, just be very careful with your steps. Solve it one at a time until you get it. And you'll be good. You can go off and do amazing things. So, take your time, be very careful as you set these up, and you will get it in the end. So I hope this helps you, and I will see all of you next time. Have a great day. Bye-bye.